All right, let's do 1.5. Okay, match each graph with the corresponding transformation of f of x. Okay, f of x is this red guy right here. I'm looking for something that's a translation of it. That's going to be D. D is the only one that looks the same exact way as f of x, oriented the same way and everything. It's just shifted and moved. Reflection, that looks like B. Boop, flip it over, that's B. A horizontal scale, meaning they took it and they either horizontally shrank it or they horizontally stretched it. I'm thinking C, right? If we squeeze stretched it, like this probably goes. Actually, I don't know actually on this one. I still think C. A definitely looks like a vertical scale, like they smushed f of x down into A. So I'm saying this one is A and that one is C. Okay, now let's sketch transformation. Let's look at a translation left 4 units. So I'm going to take this guy, I'm going to pick him up, and I'm going to move him 1, 2, 3, 4 to the left. And then all the points got to move 4 to the left. All of them. So from here, this guy's going to do that. Reflected over the y-axis is over here, this guy. So here, we'll flip here. This guy will flip here, and there we go. Scale it vertically by a factor of 3. You guys, we didn't really get a chance in class to go over it in this much detail with the scale factor and like the exact amount that it was scaled. I'll show you. Here's how it goes. Vertically scaled by a factor of 3. When this number is more than 1, that means it's a stretch. Like it got bigger. So this is going to get vertically stretched by a factor of 3. What I do is the middle center point right here stays. Then this point right here, that's just 1 over. Well, if it's getting stretched vertically by a factor of 3, when I go 1 over, instead of going only up 1, that's how much this goes up, I'm going to go up triple, because that's a 3. 3 means triple it. So 1, 2, 3. Oh boy, my kids are fighting and one of them's about to come in here yelling. Okay. Here we go. Let's see what happens. There we go. Okay. All right, let's look at this one. Scale it horizontally by a factor of 2. So again, the 2 is more than 1, which means it's a stretch. So we're going to horizontally stretch this guy. So we're going to pull him horizontally, make him bigger, not smush him. We're not going to shrink by a factor of 2. So this guy's going to stay like this. The center will stay the center. And then now, this... I don't know if you just heard it, but my son just called my daughter the worst. Okay. So this one went up 1 over 1. Well, if we're going to double it, horizontally stretching it, it's going to go up 1 and over 2. Up 1 and over 2. Like that. Okay? Alrighty. Okay, let's keep it going. Let's describe how to transform each graph so that it goes through the points that are labeled. Well, for 6 and 7, you guys have a buttload of options, like so many. So, like, for example, for number 6, I could just pick this up and move it. let's say 1, 2, 3, 4, 5, 6, 7, 8 to the left, and 1, 2, 3, 4 up, and draw the exact same thing over here. So this would be translated horizontally, 8 to the left, and vertically 4 units up, okay? And we can do that here too. However, I do kind of think it's easier to flip this guy upside down. So, but could I have done exactly what I did in number 6? Yeah, I could have brought it down and over. But this I just think a horizontal reflection, I'm sorry, a vertical reflection is less work for me, and I am lazy. So that's where that's going to end. And here, describe at least 3 different ways to transform it. Well, here we go. 3 different ways. We only know 3. So they want one using translation, one using reflection, and they want one using scale. They call it scaling, which we know is dilation. So translation will go down 4, left 4. If we're going to go a vertical reflection, on its own won't put us through that point. But we could do a vertical reflection. And, is it this guy? 1, 2, 3, 4. That one goes down. 1, 2, 3, 4. Yeah, this point. And we would still have to move to the left 2. So vertical reflection plus left 2. So that's a translation. A horizontal one. And then scale. Again, I think it would require a vertical reflection plus a horizontal scale so that it stretches and goes through that. So plus horizontal scale. Okay, that's super messy, but that's 3 different ways. Are they the only 3 ways? Absolutely not. I don't know what you came up with. I'm curious. Doesn't mean you're wrong if it's not what I got. Okay, let's look at the spiral review. A translation is represented by the rule. Ooh, you guys, maybe you saw this last year, maybe not. Geometry does this kind of stuff, I think. So this is a translation. They're giving it to us by this rule. What's the image of 0.36 going to be? All you got to do is plug 3 in for x and 6 in for y, because points are given as x comma y. So we're going to say that this is 3 minus 2 comma 6 plus 2. All I did was take this and plug in these numbers. So that becomes 1 comma 8. And this one, a translation moves the origin to the 0.34. What is the image of 0.15 with the same translation? All right, origin is 0, 0. 0, 0 turned into 3, 4. How'd that happen? Well, the x got added 3, and the y got added 4. You could do it like this. This is the algebraic way. Now you could just plug in the 1 and the 5. So 1 plus 3, 5 plus 4. And that is 4 comma 9. If you're a visual person, put 0, 0 on the graph. Put 1, 2, 3, 4, 5. Put 1, 5 on the graph, and notice what happened. It went right 1 and up 5. So then you can plot 3, 4. And also move that right 1 and up 4. And so you'll see that it landed at 4 comma 9. Whatever way. Lots of ways. Okay, guys. I hope that was helpful.